Hello friends, in this video we are going to discuss about the working of SMPS circuit or power supply circuit. A switching mode power supply, which is shown in the figure, the bridge rectifier and the capacitor filter are connected directly to the AC line to give the unregulated DC input. The thermistor RT limits the higher internal capacitor change current. The reference regulator is a series pass regulator. Its output is a regulated reference voltage V reference, which serves a power supply voltage for all other circuits. The current drawn V reference is usually very small, which is about 10 mA. So the power loss in the series pass regulator does not affect the overall efficiency of switched mode power supply SMPS. Transistor Q1 and Q2 are alternately switched off and on at 20 kHz. These transistors are either fully on at 0.2 volt or at cutoff, so they dissipate very little power. These transistors drive the primary or main transformer. The secondary is central tapped and full wave rectifier is achieved by diode D1 and D2. This unidirectional square wave is next filtered through two-stage LC filter to produce the output voltage V0. The regulation of V0 is achieved by the feedback circuit consisting of a pulse width modulator and steering logic circuit. The output voltage V0 is sampled by R1 R2 divider circuit, which is compared with the fixed reference voltage V reference in the comparator 1. The output of the voltage comparison amplifier, which is called V control, as you can see in the figure, V control is applied to the negative input terminal of the comparator 2, and the triangular waveform of the frequency, which is about 40 kHz, is applied at the positive input terminal. It may be noted that a high frequency triangular waveform is being used to reduce the repulses. That comparator 2 functions as a pulse width modulator, and its output is square wave of period t at a frequency of f is equal to 40 kHz. The duty cycle of a square wave T1 over T1 plus T2, which varies with the variation of V0. The output VA derives the steering logic circuit shown in the dashed box. It consists 40 kHz oscillator cascade with a flip-flop to produce two complementary outputs, VQ and VQ bar. These waveforms are applied to the base of transistor Q1 and Q2. Depending upon whether transistor Q1 and Q2 is on, the waveform at the input of the transformer will be square wave, where VB is the rectifier output. After the inspection of figure, we can see the output current pass through the power switch consisting transistor Q1 and Q2, inductor having low resistance and the load. Hence, using a switch with low losses and a filter with high quality factor, the conversion efficiency can be exceed up to 90%. If there is a rise in DC output voltage V0, the voltage control V control of the comparator 1 also rise. This changes the intersection of V control with the triangular waveform, and in this case the time period gets decreased. This in turn decreases the pulse width of the waveform driving the main power transformer. Reduction in pulse width lower the average value of DC output V0, thus the initial rise of the DC output voltage V0 has been nullified. So far we have discussed the operation of SMPS. Now we shall be able to justify why SMPS has better efficiency than the linear regulator power supply. We have noted that very high frequency signal about 40 kHz or more are being applied. The transistor Q1 and Q2 are acting as the switches and becomes alternately on and off at the frequency of 20 kHz. Again, the transistor Q1 and Q2 is on for very small duration and consumes negligibly small power, about 0.2 volt, which is very small. It may also be noted that the high operating frequency used for switching transistor allows the use of smaller transformer, capacitor and inductors. This allows a decrease in size and cost. There are some limitations and precautions to be taken with the switching power supply. Since the rectifier is tied directly to the AC line voltage, the rectifier's capacitor and switching transistor must be able to withstand the peak line voltage, which is about 310 volt to 220 volt AC RMS line. A resistor R must be provided to prevent unchanged capacitor from shorting out the line while initially turned on. A switched mode power supply is more complex and required external components like inductor and transformer. It is slow in responding to transient load change compared to the conventional series regulator. One should be carefully about the electromagnetic and radio frequency interference while using the switched mode power supply. As can be seen, the switching regulator system is quite complex one. However, with modern microelectronics, quite a few packages are available. The Motorola MC 3420 by 3520 is a pulse width modulator IC chip. The Silicon General SG1524 produces an IC package containing reference regulator, pulse width modulator, consisting sawtooth oscillator and comparator, and the comparator 1 and transistor Q1 and Q2, the steering flip-flop and 2 NAND gate. Now we can summarize the voltage regulator chapter with the help of few points. First is, a regulated power supply provides a DC voltage independent of the load current, temperature and the AC line voltage variation. A regulated power supply has 4 parts: reference voltage circuit, error amplifier, a series pass transistor and feedback network. Third is, there are several IC regulators available. 78XX, 79XX series are 3-terminal positive and negative fixed voltage regulators. Fourth is, the IC regulators combine the reference voltage source, error amplifier, pass transistor with short circuit and current limiting and thermal overload protection. Fifth point is, the 723 regulator can give adjustable output voltage in a wide range. It provides short circuit protection and current fallback using external components. The basic regulator can be current boosted with the external base transistor. The sixth point is, the switching power supply allows a decrease in size and cost. The pass transistor here are switched on and off at 20 kHz or faster. The output level is controlled by varying the pulse width of the switching waveform. Operating at this frequency allows the use of smaller transformer and capacitor and inductors.